ThreatX's runtime dashboard provides a comprehensive system overview of your runtime environment. The timeline provides an overview of all historic event activity with the ability to distinguish between various classifications and apply filtering based on application, commands, tag classifications, rule sets, and risk. Rules can be also customized to detect and block specific events based on an organization's security requirements. With this toolset, security analysts can quickly stop threats and identify risk, malicious or anomalous events for further investigation. Let's start by using ThreatX's system browser in the runtime dashboard to observe all runtime traffic and suspicious events being detected by ThreatX's RAAP sensor. Users can drill into high-risk events running on their workloads by using the dashboard's Miller column filtering to quickly and easily begin investigation. Now that we're looking at all high-risk traffic, users can drill down into even more specific classification or rule details. Classifications is based on the MITRE framework for identifying attacker behavior. ThreatX rules capture specific traffic patterns and behaviors, and each rule is aligned to a specific classification. For this use case, let's go ahead and dive into the command injection activity being detected by ThreatX's runtime dashboard. Here, we can see all of the matching criteria for each event running on your applications. Now that we've selected command injection, we can see that there are two commands that are being picked up by ThreatX that are considered command injection: mount and whoim. Let's start by investigating the volume enumeration event with the mount command. The mount command allows users to mount or attach additional child file systems to a particular mount point on a currently accessible file system. The command passes the mount instructions to the kernel, which completes the operations. Attackers can use the mount command to mount a malicious payload to a file system to attack workloads. This is used, for example, when plugging in a USB to take over a machine. Now that we've drilled into this current event's details, we can see what specific rules have triggered this event by looking at the trigger conditions on the upper right-hand side. We can see both rules were detected for command injection as well as volume enumeration, with combination with the current timestamp and IDs for the process and UID and GUID. If we look above, we can see the timeline of how many times mount was used, as well as when it was actually executed upon as well. But the big question to answer is, where did this process come from? This is where we can start to use ThreatX's process graph. This will help security analysts pinpoint which application this command came from and when it was executed. Security teams can gain the visibility needed to begin triaging and continue locking down this application to prevent further spread of any malware that was attached using the mount command. Also, within the current event details, security analysts can understand specific environment variables so they can further triage what systems were potentially infected. This is just one example of how ThreatX's runtime dashboard can help security teams identify high-risk traffic and begin to investigate runtime activity that could potentially be putting your workloads at risk. Jumping back to ThreatX's system browser, now we can start to look at more specific malicious commands that are being executed within runtime environments. Let's start to drill down into anomalous traffic that's trying to enumerate through all of the available directories and files running on this given workload. We can do this by filtering the commands by the ls command. The ls command is a Linux command used to list file directories, and this can be used from an attacker's perspective to identify valuable files that contain sensitive information or rewrite file permissions for ransomware attacks. The timeline view at the top of the system browser also reflects when and where this command has been executed, how many times, and will help security analysts understand the context needed around if this is malicious or anomalous behavior. Let's begin investigating this event by drilling into the specific details around the trigger conditions, again identifying which rule ThreatX matched this behavior against, the timestamp, and we can also see more context around the actual command line attempt that was executed on this Apache 2 application. To answer the million-dollar question as to where this command came from, we can again use the process graph below. Security analysts can use ThreatX's process graph to tell a more cohesive story about other commands that were being executed alongside this ls command. For example, if we highlight the netstat node, we can start to look at the specific information around the netstat command being used by attackers to potentially see network connections and understand where they can spread the next attack to. By understanding the process's child nodes and child commands together, ThreatX can help security analysts piece together a more cohesive story around the commands that are being used to take over this cloud workload and execute a more cohesive attack. Now that we can confirm that there's malicious traffic indicative of an attack by investigating further into this ls command by seeing all the relevant events, security teams can begin triage and locking down this application as well. These were just a few examples of how ThreatX's runtime protection dashboard can help your team to identify and observe evolving runtime threats in your environment.